to pose the question, so that it's not just
Great.
me reading questions.
Wonderful. Thank you.
Yep.
Okay. First of all, thank you for inviting me to present today. I love sharing the work that we do, and would love to help in any way if there are questions on best practices and ways to manage and access groundwater data. So I am going to talk about USGS groundwater data, specifically how we collect our data, database management, and data access. During this session, I have multiple presentation documents, but I will share those with you in the end. I wanted to break it up a little bit in case we needed to go into discussion on one part or the other. First of all, I'll give you an overview of USGS groundwater data. Then we will discuss the considerations for and methods for collecting groundwater data. How do we collect it? What types of things do we consider as we develop projects and programs around groundwater data and groundwater information? Then I will give you an overview of managing groundwater data and quality, of how USGS manages data quality. We will also talk about storing groundwater data. We have the National Water Information System, which is our national database. I'll talk about the content and the structure of that database. And finally, I'll go over a few ways that we visualize groundwater data and retrieve data. And I'll do some demonstrations of how those systems work. What I'll describe is our NWIS web, our public-facing side of our NWIS database. Also, NWIS Mapper, it's a map interface for accessing data. Water Services, which is a service that was developed for large data retrievals and for data mining. So it's not a portal or interface that an individual will sit at a computer and access the data. Rather, scripts can be run and programs can be programmed against the services. Groundwater Watch, I'll go over that. Groundwater Watch is a value-added product for our public-facing data. Geolog Locator, Groundwater Web Flow Tool, which displays models, groundwater models that have been developed across the nation. We'll also talk about national networks, the National Groundwater Monitoring Network, and if we have time, the Water Quality Portal. I did provide some links to all of these resources so that if you wanted to, you can access them on your own. So first of all, let's talk about USGS groundwater data. The type of data that we collect are water levels, aquifer characteristics data, water quality data, and water use data. These are all collected for a variety of reasons, a variety of purposes and objectives. They're all stored in the same database, no matter what the objectives and the purpose of the study was, but they are part of national programs as well as cooperative projects and basic data programs that are nationwide. Our data have been collected for more than 100 years, so we do have quite a few sites that have long-term data available for retrieval to the public for retrieval. As I mentioned, data are collected for a variety of objectives and purposes, but generally they're divided into two different categories. There's the network, or what we call surveillance networks. These give an overview of the groundwater across the nation. And then there's investigative studies, or what we refer to as research studies. Those are very specific, defined by very specific parameters of the study. Within those categories, There is baseline data. Baseline data, what we mean by that is we get information for determining the future changes from the initial or baseline conditions. The baseline data establishes a benchmark for future investigations. There's also long-term monitoring. Long-term monitoring looks at temporal trends or changes over time, and are often needed for calibration of groundwater models and things like that. There's also intensive collection of data for geohydrologic characterization. This type of data are collected to better define aquifers and confining units. Depending on the scale of the investigation, it can be very expensive to do these intensive collection networks. They could include things like borehole drilling, geophysical surveys, water quality samples, water level data collection, grain size analysis, mineralogical analysis. All of these things can be done during one of the intensive collection projects. Finally, they could be used, part of the studies include defining a specific problem or research. For example, data collection could be used to delineate the extent of saltwater intrusion for a regulatory or a water management agency. Let's see. So some common questions that come up for why we would want to collect groundwater data that have to do with occurrence and availability. Where is the data? So people want to know, they don't want to waste time on drilling dry holes. They want to make sure if they want to access data, they want to make sure they know where the water is. So there are questions on occurrence and availability of groundwater. Also, how much is there is a common question. Sometimes you can get some idea of this type of information by compiling well yield data to answer some common questions. But it really is asked to know what resources are required to access the data or to access the aquifer, how much water is available. We also want to know how good is the water, what's the quality of the water. Things like we will do water quality testing to see if there's bacteria or pesticides or radionuclides in the water, anything that might affect human health. Another common reason for collecting groundwater data is to understand at what rate can water be withdrawn, how much can I use? So determining a safe yield of a well can be complex and require quite a bit of groundwater data. Another question is, how long will my resource last? How long can I use this resource? Similar to question number 4, to answer this question, you need to know long-term trends or long-term recharge or hydraulic properties of the aquifer so that you can assess how long your resource will last. Another question that's common is in what direction is my water moving? And to answer this question, you may collect data and use it to build a potentiometric surface map or to assess groundwater flow and create a model for groundwater flow. And finally, another common question is how fast is that moving? Is the water moving? What's the hydraulic conductivity or the volume of water that moves through my system over a certain time and under a hydraulic gradient? So common uses of groundwater data. We use the data to locate aquifers and evaluate the volume of water available. In order to do this, you may want to evaluate and the data are used to evaluate and define the aquifer system, to evaluate the status of the groundwater system, to estimate past, present, and future uses or effects of the system of groundwater, of the aquifer system, sorry. And also to estimate the effects of land use on groundwater or provide useful information to managers or lawmakers. Another use of water, groundwater data is to look at wellhead and streamhead protection areas. Who uses the data? Who uses USGS groundwater data? Quite a variety of users, from internal folks for research purposes. We also have folks from municipalities. Those are cities or local government agencies. Also state government agencies. In some states, the state owns the groundwater resource and must appropriate its use. So they'll use USGS groundwater data to decide how to appropriate water use. Federal agencies also are users of, large users of groundwater data from USGS. The Department of Interior, for example, manages a lot of the Western lands and land use, and they also use our data. Industries such as agriculture, thermoelectric, and manufacturing also use the data, things for like heating and cooling and processing of water, or the data, groundwater data are frequently tied to irrigation, and they may need to know, ask some of those questions that we talked about earlier. Availability, how much is available and how long will I have the resource available to me? Consulting and engineering firms use groundwater data. They frequently request data and reports. We are forbidden to give access to data that has not been approved by our director or have been deemed not available to the public. I could talk a little bit more about that when we get to the database and how we partition out the data that may have a data agreement that might restrict some of the release of that information. And also individual citizens. Individual citizens use groundwater data for a variety of reasons. USGS does have a policy that all data and information that's gathered through our investigations and observations by USGS staff or contractors must be made available to the public unless there is some sort of agreement that would restrict or that's restricted by law to make that information available. So the vast majority of the data that we collect are made available to the public. Okay, so let's talk about collecting data. What types of things do we consider when we are establishing a groundwater monitoring program and the methods that we use to collect data? So as I mentioned earlier, groundwater data are collected for a large variety of reasons, purposes, and scopes of studies, regional, national, local interests that can be projected onto a national or regional issue or a problem. Before you design a program, or as you design a program, you want to make sure that the sites that you select meet your criteria for the objectives of your study. You want to make sure the sites are suitable, the wells and what you're collecting data from is good integrity, and we'll talk about how we verify well integrity. You want to make sure it's accessible. Can I get in and out of my site with no problem so that I can collect the data as frequently as I need to? And construction. You want to make sure that the sites that you select are screened or open to the proper aquifer, are in a location where maybe it's along a flow path that you're interested in, but you need to know a little bit about those sites before you make a selection and include them in your study. Also, something that we consider is the frequency of water level measurements. We'll talk about that a little bit later, where the advantages and disadvantages of something like a periodic measurement or a discrete measurement every once in a while, like monthly, or the advantages of setting up instrumentation at your site so that you can get 15-minute data, hourly data, or daily data. And you also want to consider the quality assurance requirements for your study to make sure that that it meets the sites that you select meet the criteria for your study. Okay. Okay, so let's talk about measurement frequency. It's often influenced by the economic considerations. It can be expensive to monitor a site daily or put an instrument into a site and monitor it continuously. So depending on the objectives and the economic considerations of your study, you may decide that it's you can get the information you would like and need for analysis without having to install expensive instrumentation, but to go out and manually measure. You want to make sure that you have adequate coverage for variability and level fluctuations. For example, if you are looking to detect short-term or seasonal patterns, you want to select your frequency accordingly. If you're looking to differentiate effects of short and long-term stresses, you want to have a long period of record and collect data over a long period of time, but at tighter intervals. You also want to consider your data resolution needs when you determine the frequency. This is the amount of detail needed to characterize your hydrologic behavior of the aquifer. So something to consider. We call periodic measurements or discrete measurements. These are those manual measurements that you take, you show up at the site, you open the well, and you take a water level measurement manually with an instrument. And we'll talk about some of the instruments that we use. So these can, you can record these monthly, quarterly, annually, or less frequently. For example, we have studies that will do potentiometric surface maps and changes of water levels over time, and they may go out once every year, once every 2 years to get that snapshot of water levels. Periodic measurements or discrete measurement program will capture general trends. It's suitable for like deep confined aquifers where you have relatively stable conditions. This is just a hydrograph showing you we have one measurement. This is most likely, it looks like this might be monthly or quarterly measurements over a long period of time, and you can get the general trend of your water, of your aquifer conditions. There's also continuous measurements. By continuous measurements, we mean instrument is installed in the well, a pressure transducer or a float and tape are installed, and measurements are recorded regularly. For continuous measurements, we will often record measurements every 15 minutes, hourly or daily. In our earthquake wells, as a matter of fact, we actually do a sub-second data. Lots of data are generated from those types of wells. The advantage of a continuous monitoring system would be that you would capture short-term fluctuations that you may miss if you are going out to the site monthly, annually, or quarterly. A continuous network will help distinguish between long-term and short-term stressors, such as drought and earthquake. In the first graph, you'll see where Virginia had a rare earthquake. The line, the green line you will see shows our daily values. We have one measurement every day. The instrument collects, stores, and transmits that data daily. If we only collected daily data in this situation, we would have missed that earthquake signature. So the blue line, the jagged line, is 15-minute data. So luckily, we were collecting data every 15 minutes in this well, and we were able to capture the earthquake that happened in August of 2011. So consider, again, the objectives of your study and what are you trying to capture. So a quarterly or a daily measurement may not really capture the signature that you're looking for. The other graph shows a difference between a daily measurement, which are the black boxes, and a quarterly measurement. You can see that if you only collected quarterly measurements, there's a lot of noise and there's a lot of activity in your aquifer that you may miss because you're only capturing that data quarterly, which is every 3 months. Okay, now I'm going to go over a few things that, a few ways that we collect data. So electronic, so the methods, we try as much as possible to use electronic data collection and entry and database entry methods. We do this because it minimizes data transcription errors and calculation errors. If you're writing it on a piece of paper, you get distracted, you're doing a calculation of a measuring point, you're subtracting off a measuring point from your land surface datum, you do a math error. You may not catch that early on. You may only catch it later on as you're analyzing the data. But by doing electronic data collection and data entry, we try to minimize those types of errors when we collect the data. It also helps us effectively load the data into the database and archive the data with all the metadata that goes with describing that water level measurement. Also, by using electronic collection, we have a system called SVMAC, Site Visit, what is it? Site Visit AQUARIUS. This application is set up to show you a hydrograph and a data table at the site that you're sitting at so that you can take the water level measurement and do an immediate comparison to see if that water level measurement makes sense. It helps you identify potential anomalies that may indicate well defect or equipment malfunction or error in measurement. It also forces, by using these electronic applications, it forces you to take a second measurement or a QC, a quality assurance measurement. This assures repeatability. The measurement is of good quality. When you're selecting the method that you're going to use to collect the instrumentation or method you're going to use to collect your data, there's a bunch of things that you want to consider. One of the big things is your site condition. You want to make sure that things like your well type and access to the site are considered so that you don't lose equipment or damage equipment or injure anyone in the process of collecting that data. And you also want to consider the required accuracy for your study objectives. So in this picture, you'll see this is, it was a pumping well. They put down an electric tape, and you'll see over on the right-hand side, because that well was pumping, it just pulled in the tape and the whole well had to be removed. The portion of the well had to be removed and replaced. It's a very expensive problem to have. You should never put this type of tape down a well that is pumping, or you should really know what the distance is between the water level measurement. You have a general idea of the different distance between the water level measurement and actually the pump. Okay, there are different methods of water level measurements to collect water level measurements. We use transducers to help collect continuous measurements, steel tapes, e-tapes, electronic tapes. Airline are usually put in a pumped well. Let me go back a little bit. The steel tape, let me just say that the steel tape is by far the one that's the most preferred method of discrete or periodic measurement collection. The accuracy of a steel tape is 0.01 foot. It's durable. It's unlikely to stretch or kink, so the equipment will last a long time. There are pros or cons, problems with steel tapes though. If they do kink, they can really impact your measurement. They cost a lot. There's a higher cost associated with a steel tape. And this diagram right here is the steel tape. Here we go. Also, it's possible that they can hang up in a well. So if you're not careful, if you don't have a weight or something at the bottom of that in a deeper well or even a shallow well, you want to make sure that that tape does not stick to the side of the well and give you a false reading. You can get that if you have a weight at the bottom of a tape, it's possible to get that stuck in a well, on a lip of a well where maybe two pieces of casing are joined together, and that could break away and cause some problems. But so that's kind of some downsides of the electric tape. The steel tape. The electric tape is also used quite a bit by USGS. There are several vendors of electric tape. There's very few vendors of the steel tapes. The advantages of the electric tape are that the accuracy is, again, 0.01 foot accuracy. It's a lower cost, so you can get an accurate measurement at a relatively low cost. Unfortunately, the electric tapes are a bit less durable. There are different types of tapes, but in general, they are less durable. They can stretch or shrink, and they can also get hung up in a well just like a steel tape, so you have to be careful on how you use those. The airline is used in wells commonly used in wells that have a pump installed. They do have a poorer accuracy, so you want to make sure you understand the objectives of your study before you select an airline. They're really only best to the nearest foot, so if you have a very deep well or you just want to get the general water level, you could use that, but keep in mind it's only really best to the nearest foot. And they can be difficult to read. But they are especially useful in an area where you have a pump installed or the water is actually pumping. The turbulence of the water will not really impact the measurement if you're using an airline. So the method can be used while the well is actually pumping, and unlike on the steel and electric tapes. So we also use pressure gauges. These are used for measuring. I have one example here in the middle picture at the bottom. Pressure gauges are used in wells that are flowing. So if you have a well that has quite a bit of pressure, there are all different types of these that you can use and still get an accurate water level of water flowing above the pressure of the water flowing up rather than a water level. Flow tapes and continuous recorders are used, and again, pressure transducers are used for our continuous data or our shorter term measurement recorded data. And our data are often telemetered or sent by satellite to our offices and sent to the public. And I'll talk about how we get the data to the public. I just wanted to make available, you'll have a copy of this presentation. We have YouTube videos on methods for proper procedures for collecting groundwater level data using electric tapes and steel tapes. So I mentioned just a few seconds ago how we get the data from the field for continuous records that are real time. We get the data from the field to the office. So this diagram shows that there's an instrument shelter, where the instruments are sitting. There's a power supply and a satellite antenna. There's a transducer down the well. That information is collected at whatever interval. Let's say the interval is 15 minutes or hourly. And then that is transmitted through GOES, the geostationary operational environmental satellites. and that's transmitted through GOES and to our offices and to the internet. GOES is operated and controlled by the National Environmental Satellite Data and Information Service of the National Oceanic and Atmospheric Administration, or NOAA. Each of the data collection platforms is equipped with a recorder, power supply, transmitter, antenna, and environmental sensors that collect the data. The data collection platform is programmed to collect the sensor data and then to transmit that data at certain intervals through the GOES channels. Other non-standard water level measurement equipment or methods are microgravity, and we do have a YouTube video on how the procedures for measuring microgravity, measuring water levels using microgravity methods, and also sonic, let's see, here it is, sonic measurements or radar measurements. The sonic measurements aren't used, these aren't used very often. Sonic measurements are good for deeper groundwater levels where an electric tape or steel tape are not very accurate. They're useful for wells with pumps installed. They can be difficult to calibrate, and they also have a higher cost. Also, moisture above the water level might lead to an erroneous reading with sonic meters. They have an accuracy of about 0.1 foot. So that would produce an error of about 10 foot in depth for wells that are more than 1,000 feet. So they're not used very often, but there are situations where they are more suitable. So I'm going to talk a little bit about how we manage our data and our data quality. Okay, so we have data quality documentation, policies, procedures. We have a national instrumentation calibration program. So our water level steel tapes and electric tapes, if we use the tape in the field, it is sent through a national calibration program to make sure that that instrument is suitable for collecting water level measurements, and it also identifies any adjustments that you may need to make to the measurement to account for the inaccuracy of maybe some expanding or contraction or inaccuracy of the instrument. We have technical reviews. So in the past, we went to each water science center, would get a technical review from the technical offices. We had an Office of Groundwater, Surface Water, and Water Quality. We would show up at each of those offices every 3 years and review and make sure that they are meeting all of the the USGS procedures and policies for collecting and analyzing data. We are transitioning that now. There's actually an annual process and a process that will happen for an external review every 3 years. We have written groundwater technical procedures document, water resources, mission area policies, USGS-wide survey manuals that include fundamental science practices to make sure that our data are collected in a consistent and quality assured in a consistent manner. We have techniques and methods that are designed for all types of ways that we collect all types of ways we collect data and all types of data that we collect. We also have individual offices will have policies and quality assurance plans and data management plans to document how they quality assure their data. Training. We have more than 50 courses in the USGS for USGS and external customers. We also have cyber seminars, regular cyber seminars, videos, workshops. These all range from fundamental concepts like for brand new person who is just starting to collect data to a more advanced processes like analysis and aquifer tests and modeling projects that involve model development. Some of the quality assurance procedures that we have in the field to ensure the quality of our data include periodic inspections of the well structure and reference points established at the site. Reference points are important for consistency and to put the data into context. So I will talk about that in a little bit more in a few minutes. We have routine checks of our instrumentation. Again, when you show up at the site, there's checks that you should do, but also we have a national equipment calibration program. We have a policy for well integrity testing. I'll talk about that in a moment too. If your site is involved in a routine data collection, you have to do well integrity testing to make sure that well is still in connection with the aquifer. Also, establishing fixed reference points and monitoring the stability of those reference points over time is essential for understanding the long-term data across the nation. As I mentioned earlier, we have data that date back 100 years or more, and we want to make sure that we keep that data in context. So making sure that the reference datums and the reference points are stable is very important to the quality of the data. So why would we want to check well integrity? I mentioned that we have a policy that states if you have a routine, reoccurring measurement program, that you will do routine well integrity testing. Because of the nature of wells, we will have wells or screens that get old and need to be redeveloped. And you wouldn't know that unless you really check the connection of that well with the aquifer. Geochemistry can change a borehole over time as well, and sediment can accumulate in the well. This is why we will want to check well integrity. As I mentioned, we have a policy that says well integrity should be evaluated routinely for USGS groundwater level observation wells that are part of a recurring measurement program. This includes wells. If we accept the data, we call that furnished record. If we accept the data and store it in our database, we do require that the provider of the data quality assure that data in some way and make sure that data are in the water level measurements are accurate and that the well has good integrity. So that's for our own folks as well as for anyone who's providing our data and asking us to store that data. Some examples of what you would see as a change in response in your water levels if your well is not, if you don't have good well integrity. So the first graph shows that over time, the water levels, you see that water levels are decreasing. The amplitude is still relatively the same, but you're seeing the water levels are decreasing. In this particular well, once it was pumped and redeveloped, the water levels recovered. So there's a period of that data that we may have to unapprove because the data really aren't representative of the aquifer conditions. Another example is in the second graph. You will see in red, you will see where the well screen looks like it was plugged. The water level measurements were pretty level. They didn't change very often. Meanwhile, a similar well drilled in the same part of the aquifer nearby, shown in the black line, is showing fluctuations. So we were able to see that this well was plugged, that the well did not have good integrity. It was not in connection with the aquifer. So after the well was reconstructed, you can see that the signature of the well, of the water levels, makes sense now. So just a little bit about the reference points, the concept. So land surface datum, we call that, this is a fixed and stable point with easy access for surveying the measuring point and the reference marks. Land surface datum is something like a well pad or brass marker or the outer casing of a well. The measuring point itself, this is a convenient location with easy access, and it's consistent location. You want to make sure that you're always using the same measuring point when you document your measuring point. And what we call reference marks. Land surface data is one of the reference marks, but again, reference marks are stable, persistent points with an easy surveying distance. We want to make sure these reference points are consistent because they help us put our data into context, make our data comparable among other wells, and also provide documenting the things like changes to the reference points will help us to evaluate and analyze our data. Okay. Okay. We do require that reference points are visually inspected. These are the land surface data measuring points and reference mark at each site at the site visit, and documenting any changes that you might see. If there is damage, if damage is apparent, the technician is required to document the estimated date of damage, check the vertical relationship between the land surface datum and the reference mark, and to check the measuring point correction from the land surface datum plane, when there's evident damage, so to verify that the reference points have not changed. If no damage is apparent, then what we require is that they confirm the vertical relationship between the land surface datum, the reference mark, and the measuring point every 3 to 5 years. This is an example of a measuring point, clearly marked on the casing, outer casing of the well. Again, clearly marked on the outer casing of the well. The well is surrounded by a shelter. In this case, the land surface datum is the markings on the concrete pad, and the measuring point is clearly marked so that on subsequent visits, they're always using the same point of measurement. Again, land surface datum clearly marked on the well, and the reference mark is on the concrete pad, a stable surface nearby. Okay, I'm going to go a little bit into storing our data, our database structure. I'm going to switch presentations. Liz, can I take questions now, or should I wait until the end?
Yeah, we can take questions. Nobody has actually submitted any quite yet.
Okay, great. Okay, I'll keep going then. So I'm going to switch presentations, and we're going to talk about our National Water Information Database. Uh-oh, am I at the beginning? Okay, there we go. Okay, so the U.S. Geological Survey has what we call NWIS, the National Water Information System. I'm going to do an overview of the type of groundwater data that we store in this system. I do want to point out, though, what I'm going to show you is our current system. We do have a modernization effort underway. This is driven by legislative requirements for us to look at cloud hosting and reduce our costs for maintenance of database maintenance. So we are currently using an Oracle system, and there's a high cost with maintaining that Oracle license. We do make it our first priority is to look at commercial off-the-shelf software, but to work closely with the vendor to customize it for our needs. Also, we want to look more at building the remaining functions that we need in-house where needed. Also, as I mentioned before, it's a priority with the Department of Interior and the U.S. Geological Survey to look at cloud hosting more often than our traditional approach is to host on-prem or on-premises to reduce our IT resources needed to maintain databases. So this is why we're doing a modernization effort. But for right now, I will describe our current system. We have a distributed database that's 45 servers sitting across the landscape in multiple science centers. The data are processed over a network of workstations and file servers. Parts of that distributed database, the distributed database are aggregated and served to the public via NWIS Web. I'm mentioning this because later on in the presentation, I will show you that not everything that we collect and store actually goes out to the public. And there are reasons why some of this information don't go out to the public, and we'll go into that in a few minutes. So the aggregated database pulls in data from all 45 of these servers and makes that available for retrieval so that you don't have to be sitting in any of those, all 45 of those locations in order to get information that's stored on that server. I will show a diagram of what that looks like. But our NWIS system is divided into subsystems. We have 4 subsystems that share a common reference files or reference lists, and also share a site file. All of our sites are based on all of our data, are based on site location that sits in this database. And it's managed in the site inventory or the site file, which links all 4 of those subsystems. And I'll show you what that looks like. So the 4 subsystems are the Groundwater Site Information System, or GWSI. This contains site descriptions as well as groundwater information. The next subsystem is the NWIS time series. We call this AQUARIUS. It's the commercial software that I mentioned earlier. This is programmed by Aquatic Informatics, and we use this. It contains all of our time series hydrologic data. Our water quality system, or QWDATA, contains discrete water quality measurements. And finally, the site-specific water use data system, or SWUDS, contains site water use data. This is what it looks like. So these 4 subsystems are all pulled together, and they all share a common site file. What is this site file? So Liz, I think I may hear you or someone else. Okay. So site file. Site file is required by all of the subsystems. It primarily stores location information, physical descriptors, political descriptors, and data collection methods. All the information I talked about in the previous presentation of the method that we use to collect our data, the accuracy of those measurements and the instrument, all of that gets stored with the water level measurements or with the water quality data, depending on the type of data that you collect. It keeps the data in context. So the Groundwater Site Inventory System, or GWSI. These data tables, the data tables included in GWSI are groundwater levels and the attributes of those levels, groundwater discharge, geohydrologic data. This is the sequence of geohydrologic units and aquifers for the well. It includes the aquifer names or the lithology. We record this information from the drilling log or other maybe geophysical surveys, excuse me, geophysical surveys that provide that information to us. And also stored in this table are spring information. I want to point out that I have asterisks on a few fields that are not served to the public. In this particular case, groundwater discharge is not served to the public. There's no real reason why that's not served to the public. We just haven't figured out how best to get that information out to the public. It is stored and it's available on request, and our internal users use it for research purposes. These systems have been developed over time, and tables have been added over time, and we haven't always figured out how exactly to get that data out to the public when we add these tables. The groundwater database also consists of altitude history table. This currently is also not served to the public, but it tracks changes in the altitude of land surface datum at the site over time. As I mentioned on the previous presentation, we do, if there are changes to the altitude datum, the changes to that land surface datum, we want you to, that gets recorded in the database and captured over time. And the new system that we're going to will allow us to serve that data, but the current system does not. Aquifer hydraulics, these are hydraulic tests and results for a site. We store that information. It's used for research purposes. Currently, it is not available, but again, we're looking to push that out to the public and make it accessible. Owner information and permit data. These are what we call, these pieces of information have personally identifiable information, or PII, associated with them. So legally, we are not allowed to disclose owner names, addresses, phone numbers, and things like that, specific permit information. That information can be obtained from the local entity. Many states have a database that serves that information. You can access that information, but USGS does not serve that information to the public. The data tables, information that's also stored in the groundwater tables include construction. We have a parent construction record, and then under that, we have multiple child records. So those child records include the hole, description of the hole, the depth, the diameter of the hole drilled, the casing material, the casing depth, the casing diameter, the open interval, where is that well open to the aquifer. It describes also, is it an open interval, or is it what type of opening it is? Is it a screened well? Is it a steel screen, a PVC screen? That type of information gets stored in these tables. The pump repair and measuring point information are also stored, but these pieces currently are not served to the public. Logs, if there are geophysical logs, we're no longer really using this table. We actually have a separate database that now stores that information and does serve that information out to the public once it's been reviewed. So it's not used as much as it used to be, the log tables. And again, the owner contact information, other identifiers, visit information, and other data available. Other data available is a very generic field, and it has a lot of various things in it. So it's not served to the public because it's not really a table that's used very well. General remarks. Networks, if a well or is part of, or site is part of a larger network, we do store that information and we try to keep that information together, but that is not served to the public currently. We are looking for ways to serve that so that you can make sure that all of the wells that you have in your study are kept together and can be referenced together. So that's the GWSI, the Groundwater Site Information System. The other component is the water quality data, or QWDATA. We are looking again to modernize this system as well, but that table includes samples and results for a variety of types of water quality categories. Physical characteristics of the water and the site, inorganic, organic, radiochemistry, trace metals, biological data, sediment size and concentration are all stored in QWDATA. As I mentioned earlier, the time series, this one has been migrated over to a more modern system. This is a cloud-based system for time series water data. In AQUARIUS, we process, compute, store, and display our hydrologic data, and our data are pushed to the public from AQUARIUS. As a user, you really wouldn't know the difference between where your data are coming from, whether it is any of these individual systems. It's all pushed to the data, pushed to the public. But this is just I want to give an overview of how we actually store that data. One thing I did want to point out that currently AQUARIUS is used for time series data, water levels, measuring point, altitude datum history, tables will all be moved to AQUARIUS in 2020. Okay, I'm going to kind of move on here. Water use data system, our site-specific water use data system, or SWUDS, it measures, stores measurements of estimates of water use by individual users, aggregate users, or user-defined geographical areas. There is also an AWUDS system. SWUDS is the site-specific. AWUDS is the aggregated water use data system. It is a standalone application and does not relate to the SITEFILE like the rest of the NWIS does. Because it's an aggregated system, there's no one site associated with all the data under that site. This is what it looks like. I mentioned earlier that we have aggregated all that information into a national database to make the information available easily without having to go to each of the 45 different servers. So all that data sit together in the national database. We pull it into the national database. We run it through some scripts that we call deduplication scripts. Because of the way our system is set up with 45 different servers, it is possible for duplicates to be across servers. So in order for this aggregated database to work best, we go through a process of removing those duplicates and then storing only a single copy of the piece of data for every site. And that's that automated deduplication process. And then we serve 37 different types of data on this aggregated database. So that aggregated database includes site information, discrete water levels and related well information, water quality, discrete water quality, the site-specific water use. Again, project networks, I mentioned that you can assign a network to your well so that you can keep projects wells together if you want to retrieve that data, and also related reference lists and information that are common to all of those sites. These are the topics. We call them topics, but these are the data tables that are shared onto the aggregated database. Okay, so that's NWIS. That's our database structure. Next, I wanted to go back to our presentation. So that's database structure and the database and structure. Next, I want to talk about data visualization and retrieval. So in the time we have left, I want to go through several of the systems that we have for the public-facing side of our data. I did provide this as this list and links to these as a resource and a resource list for you, and I hope you can access that. So here is the list that I provided to you, and I will go through just a few of these in the time we have left. So there is an NWIS, the National Water Information System, the web interface. That's at waterdata.usgs.gov. We have services that are built for large data miners for accessing the data using scripts and programs. That is at waterservices.usgs.gov. Groundwater Watch is, as I mentioned earlier, a value-added product that gives you more information about the long-term trends and current status of water levels. Geolog locator is that log. I'll go into a little bit of this if we have time. This stores our geophysical logs of our data and serves that information to the public. Groundwater Webflow is a model interface where you can get groundwater models that have been released to the public. It is a newer system. It is still being developed, so there aren't a lot of models on there, but you can access groundwater models that are regional and local. The National Groundwater Monitoring Network is a network that of wells that USGS contributes to and manages this portal, but it actually has data from a large number of data providers. I also gave you links to our technical procedures documents and our national field manual that ensures that we have consistent techniques for collecting and managing our data. Okay, so I'm going to go into my third presentation here, and we will talk about the public-facing side. Yes.
Linda?
Yes.
Hi, sorry, this is Clara.
Hi, Clara.
Hi, sorry, I misread the time. So I only joined a later stage, but we have a question from one of the participants, and it's on your previous presentation. So I'd like to know it now and tackle it now, or would you want to finish your presentations first?
Sure.
Address all the questions.
Let's go back and answer the question.
Okay, so Tesfaye asks how to develop groundwater data format, including all the required information for a specific investigation. More specifically, is there a particular software format or some sort of data interchange format that you can use and can talk about, or something? I think he's looking for guidance for his research.
Sure. So USGS, our scientists that collect data, we do use a consistent format. We really encourage folks to use our electronic software for collecting the data, because it makes sure that you are using the correct format of the data. The field computing software will take the data entry, for example, the water level measurement, the method, the reference points that are you using, like the measuring point that you use, a description of the accuracy, all those pieces of information. It will transform that data entry into what we call a transaction file. Then that transaction file is a simple text file that gets pushed into the database. Everything is lined up in the right tabs. It's all the structure of the actual data are consistent. The database itself, when you enter the data, it runs through some checks. So when you enter data into GWSI, it will automatically run through some checks to make sure the format is correct, that you have all mandatory fields. Some fields are mandatory, some fields are optional. It will make sure that you have all mandatory fields so that the data are consistent across the nation and throughout the data server. So we do have checks and balances to make sure that you're collecting the data in a consistent manner and that it can be used pretty consistently all across the nation because it's in that same database. Does that answer the question?
I think I'm going to ask Tesfaye to comment and unmute. Tesfaye, you are unmuted. Has Linda answered your question?
Yes, the questions are well addressed. Thank you very much.
Okay, thank you. It does help that we have those standard technical procedures. The standard technical procedures does ensure that no matter where you are in the country, if you're collecting data for USGS or you supply the data to USGS, it is consistent and it will go into the database and can be served to the public.
Thank you, Linda. Thank you. Carry on with your next presentation. I don't see any other questions.
Okay.
No, there's some question. Then, okay, now they're starting to flow.
Okay, no problem.
Thank you. So Kevin Peterson is one of the research leads for our Theme 3 research group. He asks, what criteria are useful to consider in designing a national groundwater monitoring network, and specifically criteria to guide the spatial extent and density of the monitoring network?
Okay, what kind of criteria are, let's see. Well, as I mentioned before, I think you really have to understand the objectives of your study and the network. So things you want to consider: do you need to drill wells to meet those criteria, or are there existing wells? If you use an existing well to meet the criteria for your network, you really have to understand how that well was constructed, the location of that well. It has to be obviously meet the needs of your study. One of the things that we will often do if we want to use an existing well, because it's expensive to drill wells in an area to do your assessment or to do your study, what we will do is we'll take a borehole camera and we may go down that well if we don't have a well log, if we can't find the folks who constructed the well who tell us, make sure that the well is open to the right part of the aquifer, the well is constructed well, and meets those criteria. It's not like when I take a water level, I'm getting an accurate water level that represents the aquifer system. If the well maybe is at an angle or not well constructed, the screen is not open, all those things you kind of need to know before you include existing wells in your study. So we will often put down a borehole camera and we'll look at the integrity of that well. Or we may pump the well and say, it looks like it's got a good signature, it's pumping, it's not clogged. So you want to consider, again, the location of the well, the construction of the well, the site characteristics. Is the site accessible? Can I get in and out on a regular basis? Can I safely put instruments down that well? If I can't install, if I need, let's say, if I need data collected daily or every hour or 15-minute data or sub-minute data, I need to install instrumentation in that well. So you want to make sure that the well is suitable for safety-wise. No one's going to come by and damage that equipment. The equipment won't burn out. It won't get rained on. It won't, it's protected. So you need to consider things like that too. How accessible and how suitable is my site for the instrumentation that I need in order to meet the criteria for my project? Those are just a few things. As you're designing your network, there may be other things that maybe I'm missing. I hope I answered your question though.
Thank you, Linda. I'm going to unmute Kevin and see if he has any further specification on the questions. Kevin?
Clara, no.
Are you happy with the question?
Yeah, no, I think it's fine. I'll ask a follow-up question in the context of if you're looking at a region where you don't have a regional monitoring system which is not dense enough. And the question basically alludes to what extent or does the monitoring network become statistically significant, because frequently we're working in areas where we don't have proper monitoring systems in place.
So that's a really good question, because you can't always control the density of the sites in your network. If you can use other people's wells, if you can convert, what I'm doing here is I'm also going to our Groundwater Watch page where it kind of shows how many wells, active wells we have across the nation. You may be in an area where you don't have a lot of wells. So what we would often do is we would talk to the local folks. Do they have a well that they use for irrigation, let's say, that may not be registered, that maybe you can use for your study? You may have to drill wells to fill in order to answer your question. And that can be expensive, but you would have to plan that in your network design and in the cost of your network.
Yeah, thank you very much.
You're welcome. Yeah, that can be a problem. One of the things that I'm going to just jump to a couple of things that I think might be helpful for this group as well. So we do have a climate response network, and this network has very clear objectives. We want to know what's the water level conditions that reflect climate change over time, and we want to select sites that are least impacted by human activity, not around irrigation or pumping or not a domestic well that's going to be pumped on and off, that's pretty much left alone and doesn't have a large anthropogenic signature. This is what our climate response network looks like right now. I'm showing that on the screen. You will see we have gaps, and there's nothing we can do really, because there's no suitable wells, even though if you go back to the full network, there are a lot of wells here, but they're not suitable for the objectives of that network. We may have to drill, we know that we may have to drill wells that meet the suitability that are suitable for our study. So I'm just going to show you, let's see, I'm going to look see if there's any other questions here. I don't see any. Okay. Well, thank you for the question. Okay. Yeah, thank you for the question, because I don't want to just go on about things that aren't as important to you. So if there's something that I need to touch on, just please let me know. I'm going to right now go into our public-facing side of our water data. This is NWIS Web. This is where all of the data that I showed you that we store in NWIS, not all of the data, much of the data that we store in NWIS is served to the public. We don't serve the use of the water. For example, it won't tell you that it's a domestic well, and this is for homeland security reasons. We don't want the domestic supply and the public supply wells to be compromised, so we're not giving you, we will show you the information, but we won't tell you that that's how this well is used. And that can be a problem depending on your study. If you look at the USGS wells that are scattered across the nation, you may need to pinpoint specific types of wells, and we don't give you all of that type of information. You may have to contact the local office to get it. We also don't share, like I said earlier, the public personal information, and we restrict the actual location information, the latitude and longitude for certain site types. Sites like, oh, I'm sorry, I should be actually showing this in presentation mode. I apologize. Sites that have are under litigation, have tribal agreements, those types of sites that are associated with our water supply, we may not show, for national security reasons, may not show the exact location. But NWIS Web does have surface water, groundwater, water quality, and water use data. There are about more than 7 million visitors to this site every year. In this, you can get current conditions. These are the near real-time water data. So that data that are transmitted by instrument through the satellite or telephone to the office or computer, that's what we call our current conditions information. I'm going to show you specifically the counts of the sites and data. We have 1.2 million sites across the nation that we serve data to the public from on this web portal. Of those, about 14,000 of them are real time or the near real time. 50,000 of those are we serve daily value sites, so you might get a daily water, average daily water level, or a maximum daily, minimum daily, depends on the statistic that's served. And then for surface water, we have a peak flow. So we go through do an annual peak flow measurement, and we serve that to the public as well. There are access rights, so cooperators may see more of the information than we show to the public. Mainly that is for proprietary reasons, but there you can often those information are released to the public after the restriction is gone. For groundwater, you will see 897,000 sites. That is the bulk of those sites that we serve to the public are discrete groundwater level measurement sites. We do have quite a few. The number is growing for real-time and daily value sites. So this is what that looks like. So this is NWIS Mapper. This is the map interface where you can go in and you can type in the area, a street address, a place name, or the specific site location, and you can get the information for that site. What you're showing right here in the red dots are active sites. I'm going to overlay the inactive sites. Inactive sites are sites that haven't had a measurement, a water level measurement, in the last 13 months. That doesn't mean that they won't have one soon, but as you can see, we have a large amount of sites across the nation. And as I mentioned earlier, the objectives, the purpose for these data collection varies quite a bit. So they may not, many of these may not meet the needs of a specific study. But what it does, to answer one of the questions earlier, it will allow you to see where I can potentially have a site that is no longer active that I might activate again because I need it to fill in gaps in my study. So we have a large number of groundwater sites. You can get information in tabular form, text, comma delimited, RDB, also shape files out of the mapper. I'm going to keep going through here in the interest of time. This is what I wanted to show folks who may be data miners. If you want large amounts of data, large volumes of data, and you don't want to go to a web interface, obviously that's not ideal. You want to use Python or R scripting or Fortran or whatever your programming language is to program in and pull data, large amounts of data out. We have services built for that. So NWIS Web is designed for the browser, but data miners, we have this, you can basically build in your URL to describe the type of information you want to retrieve and retrieve it in an automated fashion. The data will come out in extensible markup language or XML or other formats like JSON, common or tab delimited, KML for graphical display, and also Excel files. We have multiple services built. There's a site service. This service will allow you to find basically site information, just site information. Once you have your sites, you can then go in and do a retrieval on daily values. So this is mean, min, max, all the different statistics that we serve to the data for the different types of data that you're interested in, whether it's surface water, water quality, or groundwater. We also have a statistics web service that will give you statistics on time series sites. We don't actually run the statistics on discrete sites. It is kind of unfortunate because our discrete sites have data that go back 100 years, and these long-term sites, it would be nice often to see these statistics, but that's why we have something like Groundwater Watch that provides that for you. We also have the instantaneous values, so that each of those punches, that quarter, that sub-minute, 15-minute, hourly measurement that's transmitted to the center for the continuous measurements, those are what we call it instantaneous values. There's a water quality service and also a discrete water level service. The type of information you can get out of that, you can filter on the service. You can provide it a list of sites and say, give me the data for these sites. You can provide it a list of states or territories, counties, hydrologic units codes or HUC codes. You can build a lat-long box in your script and pull in the data that we store for that area. Other filters, you can say, I only want sites that are active. I only want sites that have been pumping recently. The site status codes are stored in the database and can be retrieved on and can be used as filters. You can also say, I only want site data from sites with well depths this greater than or between this amount, or sites that are within this national or aquifer code. So you can provide the national aquifer code as long as the local center populated that in the database. You can use that to filter and to filter your list of sites that you're pulling data from. It's a very rich database. It can always be improved, but it has a lot of information. One of the limitations is it only does, I can't remember the number right now, a certain number of individual sites. You will have to, if you want a large number of sites that you want to retrieve from, and I think the limitation is mainly because of the URL that's being built. If you want a large number of sites, you might want to say, I want these 5 states. You do it at the state level, territory level, or build a lat long box to get a larger coverage. I do apologize, I didn't get a chance to get to a lot of actual demo, and I know we're running out of time. I will provide these links to you and the presentation if you would like to go in and see how you would access our data. Please do. I'm always available for questions and follow-up. But I think I will leave it at that to make sure I capture any more questions, just in case I missed something that you were very interested in getting to and I didn't have time to get there.
Thank you, Linda. Thank you very much. Those are very interesting presentations, all 3 of them. And I was actually commenting with my colleague from the Sustainable Water Partnership that just in terms of numbers of data points that you have, I think it's a bit mind-blowing for our scenario here in the Southern African regions. Congratulations. Yeah. I'm sure you have so many data.
Yes, so we are very proud of that. We are very proud that we have so many sites and data points. It allows you to answer many listeners' questions.
Indeed, but it also means that indeed you have to be very thorough and build a database that is able to run its own checks and balances, because otherwise, you have to really work on consistency of data. Otherwise, things get lost and you can't actually really see what the impact of having so much information is unless you have a really good database to rely on for answering questions.
Definitely, you're right. We have solved that problem by putting together the procedures and for, the database forces you to document certain pieces of information for consistency. So building that into your system is very important so that later on you can access that information consistently across the nation.
Yeah, absolutely. And even to have that historical sort of perspective on what has happened, to sort of have a look at the things.
Exactly.
Yeah.
Exactly.
So I'm going to open up the microphones for everybody, so that if anybody wants to ask a question directly, you're welcome to. Can I do this? I'm going to mute everybody manually then. Unmute.
Unmuted.
Hi, it's Lindsay here. How are you doing? Good, thanks. Hi. Sorry, Sharon, I know you've left office. Are you able to talk briefly? Okay. I am fretting about this proposal because it's written.
Would anybody like to ask a question to Linda?
I guess I have a quick question. It seems like a lot of people are multitasking. But my quick question was, given the experience of the USGS, you guys have a lot of lessons learned from setting up these types of databases and just setting up data collection points. And so my question is, maybe for areas that are on the cusp of setting something up, what are those lessons learned, especially as you move into cloud serving, or the cloud? Linda?
Thank you, Liz. Linda, can you answer the question from Liz?
Okay, I'm
Linda?
sorry. Yes, I'm sorry. I was talking. I didn't realize I was muted. Yeah.
Did you get the question from Liz, though? Almost to repeat it. That's also fine.
No, I did hear the question. She asked about lessons learned. And I think it's a very good question. Lessons learned really include things like the type of data that you're collecting to make sure you consistently collect things like your measuring point, your land surface datum, the locational information about your site. Otherwise, if you're not doing that, if what we've done over time is we've added database fields. And so that means the historic information, it doesn't have as much context, but the newer sites and the newer data entry does. It makes it very hard to connect the dots. So think through your design of your database and what information you need to access very carefully up front so that later on you don't have to add new fields that you're never going to have to go, you'll never have the chance to go back and fill that information from your historic information. One of the networks that we do have, another lesson learned, is the National Groundwater Monitoring Network. That is a network that is USGS along with other data providers have collaboratively created a database. And we don't always collect data the same way across all these different data providers. So it's hard to meld USGS data with state cooperator data because we collect different information. It would be very helpful that if you're in a point where you're building a database, that you talk to the local people and find out exactly how they are collecting and what data and what information they are storing, so that as you build your database, they can talk to each other better in the future rather than being very independent and really having to work hard in programming to use data across regions and use other people's data to fill in gaps where you haven't collected data. In terms of cloud resources, we have for the last 30 years, we have been using, we've been hosting locally. It's expensive. It takes manpower to do it. It takes special programmers to do it. You have to buy licenses that can be very expensive, and hardwares, local servers stored in, that's why we have servers stored in 45 different locations. Storing and maintaining 45 servers has been very expensive. So what we're doing now is we're going to that cloud hosting. There's a cost associated with that, but it's not a local maintenance cost in a bunch of different areas across our landscape. So we have learned now that that's available, cloud hosting is a very good solution. You need to work out the details in terms of who has access and the access to the information and that type of thing. Also make sure you're very clear on the costs. You don't want those costs to be unexpected for long-term cloud hosting. But we have learned that really is now a very good option, much better than maintaining the servers locally.
Thank you, Linda. I think that's a very valid point, and one that we actually touched in discussions with our research teams within the collaboration on where the data that they gathered and how is that going to happen? What is the availability thereof? So I think I'm going to take this lesson from you and bring it into the partners meeting that we're going to have next week. Because I'm sure this information, this news will come up, this issue will come up again. So thank you for that.
You're welcome. So this network, we have, as I'm showing on the screen, 29 different agencies contributing to this network, and we point to their data. We don't actually take their data and store it. So it's a portal. But in order to do that, you really have to work out consistent language for how you all refer to different pieces of data, and it can be quite different across all of these different agencies. So working that out ahead of time is very important, and will save you a lot of hard coding programming for, you know, consistent, like a water level is a water level, right? But you'll find out there's 29 different ways of saying water level.
It could be confusing.
It can be.
Yeah, no, I think, look, this actually has come up already. So what we have done in terms of the research, there's 4 teams that are working on our collaboration, and the first research team for the first theme is actually tasked to look at the existing databases and create some sort of consistency across them.
Oh, good.
So look at what is the common language, filter it through, maybe, you know, revisit some of that language to create a commonality and to create an integrated storage system. So that's what their job is, to basically polish the data, create some sort of harmonization, because we're going across country now.
Wow. Yes. That's fantastic. I'm glad you're doing that, and would be glad to give you a presentation specifically about this particular portal and the lessons learned. We can talk to Candace about doing that. One of the other things that in terms of lessons, you've probably already gone through this, is, you know, USGS is really pushing more toward FAIR data, and I'm not sure if you have heard of the FAIR data principles, but making the data findable. No. Okay, the FAIR stands for findable, accessible, interoperable, and reproducible. And all the things that go into making data fair really should be considered upfront when you're building a new system, so that the data are as useful as possible. If people can't find it, then they can't use it. If it's not accessible, they can't actually get to the place, you know, they don't have access to the cloud or to that server, then it's not useful. If it's not interoperable, like, you know, the common language that you're working on, which is fantastic. If you haven't established a common language, then again, the data aren't useful and available. And finally, if you don't make the data reusable, and meaning document your metadata, don't just put out the data point, but put out ancillary or the metadata that describes that data point, puts that data point into context. If you're not documenting that, the data again aren't as usable. So making sure your data are fair is something to consider upfront.
Thank you for that. I'll look into that a bit more, like I said, especially ahead of our partners meeting next week, because it is a question that has bothered all of our research teams, understandably. They would like to have a common storage for all this data, because there's 4 or 5 different institutions that are going to be able to, that have to be able to access it to begin with, you know,
right.
And then going on down the line, more sustainable and usable, like you said, you know, it has to be accessible by other institutions and other entities as well.
Right.
So we'll look at that, and I will be in touch with you directly on this extra lesson on transboundary situations, because and there are a couple of lessons on your experience with USGS in transboundary situations.
Yes.
But I'll take it forward with them as well to see if there's anything a bit more specific that we can look at in terms of lessons learned from you guys, and that are transferable to our Southern African scenario. Thank you.
You're welcome. You're welcome. Thank you very much for the invitation to speak. And you do have, Jenny McGuire is going to be coming up, and she's going to talk about the High Plains Network, which covers 8 different states. And that's a really good example of a transboundary studies and long-term monitoring of the transboundaries.
Yeah, we look forward to that section as well. But thank you for today. Thank you for your time and preparation, because 3 presentations is quite something. So thank you very much for your preparation time as well as delivery.
You're welcome. Much appreciated.
Hey, just wanted to insert real quick. This is Mark Anderson.
Oh.
I also want to say thanks to Linda for all your hard work, and I think you did a fantastic job of explaining our system, and hopefully, you know, they can harvest some lessons learned going forward, as Clara has already articulated. Sorry I wasn't able to join right at the beginning, a little technical difficulty or something, but anyway, thanks.
That's okay. Well, you're welcome. And again, if I haven't answered any questions, please let me know. I just kind of prepared very generally, but if there's something more specific, then just please let me know and I'll try to get that information to you.
Thank you, Linda. We'll bear that in mind. Absolutely.
Okay, on that note, I guess let's bring this webinar to a close.
Yes, thanks, Liz. I don't think there's any other question from the audience. So thank you for the organization, Liz, and for stepping in for me earlier today. Thank you again, Linda, for the work and preparation and the presentation, and for everybody who found the time to attend from our research teams, but also from a wider network of connections that we're starting to establish through the collaboration. We look forward to see you again next week. We'll send invitation for